Have you ever looked at a globe and wondered, why don't commercial airplanes fly straight across the Pacific Ocean between places like the US and Asia? Wouldn't it be faster to just go straight over? Well, the answer is way more fascinating and a little shocking than you might think. From the shape of the Earth to fuel economics, jet streams, safety protocols, and even geopolitics, there's a lot more going on in the sky than meets the eye. In this video, we're diving deep into the real reasons planes avoid the Pacific. And by the end, you'll never look at a flight path the same way again. The Earth isn't flat, it's curved. Let's start with a biggie. The Earth is a sphere, not a flat map like the ones we see in textbooks. On a flat map, the shortest distance between 2 points looks like a straight line. But on a globe, the shortest path is what we call a great circle route. If you fly from Los Angeles to Tokyo, the shortest route actually curves north over Alaska and Russia, not west across the Pacific. That curved route is literally shorter than flying straight across. It just looks longer on a 2D map. Pilots and airlines follow these great circle routes to save fuel, time, and money. The Pacific Ocean is massive and empty. The Pacific Ocean is the largest and deepest ocean in the world. It spans over 63 million square miles. If a plane were to experience an emergency mid-flight over the Pacific, there are very few airports to divert to, and virtually no nearby land for a safe emergency landing. Compared to flying over land where airports are frequent, Pacific is just open water and isolation. Airlines, especially those operating under strict safety regulations, always plan routes within a reasonable distance of diversion airports. This is called ETOPS, Extended Range Twin-Engine Operational Performance Standards. Planes aren't banned from flying over the Pacific. They just avoid the central empty part of it when they can. Jet streams and fuel efficiency. Jet streams, fast-moving air currents in the upper atmosphere, play a huge role in modern flight paths. Flying with a tailwind jet stream can save hours and tons of fuel. Flying against it can burn extra fuel and increase turbulence. That's why flights going east and west often take different routes. Westbound flights usually arc further north to avoid jet streams. Eastbound flights often ride the jet streams for a smoother and faster trip. Fuel is the most expensive cost for airlines, so even a 2% savings on fuel can make or break profitability on a long-haul route. Safety, diversion, and regulations. Let's talk safety. You've probably heard the phrase, "What if something goes wrong?" Over water, you can't just pull over. You need to follow ETOPS, regulations that determine how far a twin-engine aircraft can be from the nearest diversion airport. That's why you'll often see trans-Pacific flights taking routes near islands like Hawaii, Alaska, or coastal Asia. These aren't scenic routes. They're strategic safety corridors. Also, military zones, restricted airspace, and turbulence avoidance all shape these flight paths. The polar route mystery. You might have noticed that some flights from the US to Asia go over the North Pole or near the Arctic. These polar routes are not just for dramatic effect. They're the shortest path between many Northern Hemisphere cities. For example, New York to Hong Kong or Chicago to Beijing. It's faster to fly near the top of the globe than over the vast Pacific. However, polar flights have unique risks. Solar radiation spikes during solar flares. Magnetic navigation gets tricky. Extremely cold temperatures affect engine performance. Still, with modern aircraft and tech, these routes are safe, efficient, and increasingly popular. Geopolitical considerations. You'd be surprised how much international politics can affect your flight path. Some countries restrict airspace to foreign airlines or charge huge fees to pass over. There are also military zones, areas of conflict, and national no-fly zones that pilots must steer around. For example, during the Cold War, flights avoided Soviet airspace entirely. Even today, air routes may avoid North Korea, Iran, or other sensitive regions. This leads to, you guessed it, longer but safer routes, especially over the Pacific. The illusion of inconvenience. So why does it seem weird that planes avoid the Pacific? Because maps lie to us, or at least they mislead us. The Mercator projection, used in most classrooms, distorts size and distance, especially near the poles. It makes straight routes look curved and short routes look long. In reality, Those strange-looking curved flight paths are actually the most efficient, safest routes you can take. In fact, your plane is often flying on an arc directly calculated by Earth's curvature, wind patterns, and geopolitical stability. So next time you're on a flight tracking screen and you see your plane arcing over Alaska instead of cutting across the Pacific, just smile.
Yeah.
Now know you're flying the shortest, safest, and smartest route possible. From jet streams to Earth's shape, from politics to pure physics, it's all part of the science and strategy behind global air travel. If you learned something new today, hit that like button, subscribe for more mind-blowing geography and aviation breakdowns, and drop a comment below if you've ever taken a flight that flew over the Arctic or curved in a way that surprised you. And remember, nothing in aviation is random. Every curve has a purpose.